So our topic for today is all about ordinary differential equations, specifically linear differential equation of the first order. So we are given that the m function of m, where x comma y dx plus n function of x comma y dy equals to 0. So if this equation can be expressed as first this one, first this one, dy plus y times p of x dx equals to q of x dx, then its integrating factor, this one is integrating factor, is equivalent to e raised to exponential of integral of p of x dx. And then solving further for our equation, for our differential equation, so we will have dy is equal to integral of b q of x dx plus c. So this one first, and then the second one is this, and the third one is this. But if our differential equation is given with this one, which is equivalent to dx plus x times p of y dx, sorry, that's dy, supposed to be dy, is equals to q of y dy. Then its integrating factor is exponential of p of y dy. Solving for our differential equation, so we will use this one. V of x is equal to integral of b times q of y dy plus c. So to see this, to further, let's try example number one. So we are given that two quantity y minus 4x squared quantity dx plus x dy equals to 0. So first, I'll just distribute 2. So we will have, I'll just change my ink. Uh, so we will have 2y minus 8x squared. So I'll just distribute dx also. So we will have dx, then dx plus x dy equals to 0. And then uh, I'll just transpose this one into this formula. So we will have this formula dy plus y times p of x dx is equal to q of x dx. So you can see this will become our first term. So we will have x dy, and then our y times p of x dx, which is equivalent to, just change my ink, so plus our yp of x dx, which is equivalent to this. So we will have 2y dx. And then this one, because this one is qx dx, I'll transpose this one to the right side. So we will have 8x squared dx. So as you can see, I should divide both sides of the equation by x, and then by x. So as you can see, x will cancel out on the first term. So we will have only dy on our first term. So it's supposed to be dy, then plus 2 times y dx all over x. And then our px dx on the second term is this one, 2, and then dx over x. So that's going to be our p of x dx. And then this one is y is equal to, so this one will cancel out. So it is equal to 8x dx. So you can see this one is our q of x dx. So we will have, it turned out that our equation will become dy plus y quantity 2 dx over x is equal to 8 8x dx. So as you can see, our integrating factor, so our integrating factor will become e raised to exponential of p of x dx is equal to exponential of integral. Our p of x dx here is this one. So I'll just change my ink. So this one is our p of x dx. So we will have 2 dx over x. So integrating that, we will have exponential of 2 ln x. Using the rules of exponent, so we will have e raised to ln x squared. So as you can see, e and then ln will cancel out. So we will have our integrating factor as x squared. Moving to our third step, which is vy, this one, we will have vy is equal to integral of b times q of x dx plus c. So as you can see, our v is equivalent to x squared multiplied by y is equal to integral of our v, which is equivalent to x squared, multiplied by q of x dx. Our q of x dx is this one. This one is our q of x dx. So we will have 8 sorry 8x dx plus c. Then simplifying further, we will have x squared y is equal to integral of 8x cubed dx plus c. So integrating this one, we will have x squared y is equal to 8x to the fourth all over 4 plus c. And then 4 and 8 will cancel out. So it turned out our equation will become x squared y is equal to 2x to the fourth plus c. And that's the answer. So moving forward into our second problem. So as you can see, we have y prime is equal to, we are given that y prime is equal to x minus 2y. I'll change our y prime into dy over dx. So we will have dy over dx is equivalent to x minus 2y. Multiplying both sides of the equation by dx. So we will have, I'll just change my a. So we will have dy is equal to x dx minus 2y dx. As you can see, this, I'll just change my ink. As you can see, this one is going to be our q of x. Sorry, our p of x. This will become our p of x dx. And this will become our q of x dx. So first, I'll transpose our p of x dx to the left side. So we will have dy plus p of x dx is equal to q of x dx, right? So transposing, so we will substituting, so we will have dy plus our this should be y plus p of x dx. So we will have plus 2y dx is equal to what's retained on the right side, which is q of x dx. So we will have x dx. So as you can see, we will now get the integrating factor. So integrating factor is equivalent to v is equal to exponential of integral of p of x dx, which is equivalent to exponential of integral of this one 2 dx. So we will have 2 dx. Then the answer will become e raised to 2x. And then um, now we've got the integrating factor. So we will have vy is equal to integral of b times q of x dx plus c. So this will become our integrating factor, right? So by substituting, we will have uh, e raised to 2x multiplied by y is equal to integral of our b, which is equivalent to e raised to 2x multiply by q of x dx. Our q of x dx is x dx. X dx. Let's see. So as you can see on our integral, we will use integration by parts in here. So first integrate we will first integrate this one. So integral of e raised to x dx. So integrating that. So we will let u using integration by parts, which is u v minus integral of v du is equals to integral of u dv. So I let u is equals to x, and then taking the derivative of what, we will have dx. So, and then taking dv as e raised to 2x dx, integrating, so we will have v is equal to 1 half e raised to 2x. Substituting this one, our variables, this one, into our formula into this. So such as substituting that, so we will have u times b, which is equivalent to 1 half x exponential of 2x minus 1 half integral of e raised to 2x dx. And then integrating further, we will have 1 half x e raised to 2x minus 1 half multiplied by 1 half for the correction factor, then exponential of 2x. So that's going to be our integral for x e raised to 2x dx. So simplifying further, so we will have 1 half x e raised to 2x minus 1/4, am I right? 1/4 e raised to 2x, which is equivalent to integral of x e raised to 2x dx. Substituting this one into our solution, we will have e raised to 2x multiplied by y is equal to, what's that? Uh, Integral, so we will have 1 half x e raised to 2x minus 1/4 e raised to 2x plus c. So multiplying both sides of the equation by by 4 e raised to negative 2x, we will come up with this answer. We will have y is equal 4y, sorry, 4y is equal to 2, and then x minus 1 plus c, and then e raised to negative 2x. So that's the answer. Now moving forward into our third problem. So we are given that y prime is equal to cosecant x plus y cotangent x. So by inspection, uh, you can see that this part of on this term, this will become our y multiplied by p of x dx. So now let's try answering. Uh-huh. So I'll just change my ink. So I'll change y prime into dy over dx. So we will have dy over dx is equal to cosecant of x plus y cotangent of x. Multiplying both sides of the equation by dx. So we will have dy is equal to cosecant x dx plus y cotangent of x multiplied by dx. And then I'll transpose this one to the left side. So we will have dy minus y cotangent of x is equal to dx, sorry, I forgot the dx, is equal to cosecant of x dx. And then, as you can see, it's already in the form of dy plus y multiplied by p of x dx is equal to q of x dx. So as you can see, we will now get the integrating factor. So the integrating factor of this is v is equals to exponential of integral raised to integral of p of x dx. So in here, we will have exponential of integral of cotangent of x. Sorry, negative cotangent of x dx. So because in this, on the second term, this one, we should include the negative. So this will become our p of x dx. As you can see, as you know that cotangent of x is equivalent to cosine of x all over sine of x. So we will have this. So we will have dy minus, plus y quantity negative cosine of x all over sine of x dx is equal to cosecant of x dx. And then, we know that our integrating factor is equivalent to integral of this one. Integral of this one. So we will have v is equals to exponential of integral of negative cosine of x all over sine of x dx. Then, to integrate this one, I will let u is equivalent to sine of x, then du, which is equivalent to negative, which is cosine of x dx. We know that in our numerator, we have negative cosine of x. So multiplying both sides of the equation by negative 1, so we will have negative du is equals to negative cosine of x dx. Substituting, so we will have integrating factor is equal to exponential of integral of negative du over our sine x, which is equivalent to u. So integrating, now we will integrate, so we will have negative ln of u. And then this is also equivalent to exponential of ln of 1 over u. So our e and ln will cancel out. So we will have 1 over u as our integrating factor. We know that u is equivalent to sine of x. So we will have 1 over sine of x. We know that this one is also equivalent to cosecant of x. Cosecant of x, which is will become our integrating factor. So substituting this one into our formula, vy is equal to integral of v times q of x dx. So we will have our v, which is equivalent to cosecant of x multiplied by y is equal to integral of our v, which is equivalent to cosecant of x multiplied by our q of x, which in this case, this one. So by cosecant of x dx. And then integrating further, so we will have cosecant of x times y is equal to integral of cosecant squared x dx. We know that the integral of that is negative cotangent of x plus c. So we will have negative cotangent of x plus c. And then, transposing this one to the left side, so we will have y cosecant of x plus cotangent of x is equal to c. That's the answer.